Today on How It's Made. Three-dimensional commercial signs. We'll visit a workshop that takes pride in its hang-ups. Hardwood floors. The production process, step by step. Corrugated polyethylene pipe, a topic guaranteed to be draining. And mattresses. We lie down on the job for this report. There's nothing like an eye-catching commercial sign to attract customers. Many signs have three-dimensional lettering or decoration. Whether you hang a small plaque, an old-fashioned shingle, or a huge overhead sign, a business name in 3D really stands out. These signs are made of high-density polyurethane foam, a material that's waterproof and very durable. The sign starts out as a line drawing, which they render into 3 dimensions using specialized software. They send the file to a computer-controlled router that carves the design into a piece of foam. The router can be outfitted with various blades to get different effects, such as rounded edges, or this faceted effect known as prismatic lettering. Once they've finished carving the design, they switch the router blade to an end mill, a cutting tool that slices straight down through the foam. Guided once again by the computer, the router gradually detaches the design's components. After coating the pieces with primer, they spray them with 2 to 3 coats of polyurethane paint. It dries to a durable, hard-as-plastic finish. This design calls for gold and black lettering. They'll use gold leaf instead of gold paint because it lasts longer and has finer color and luster. First, they brush on special glue for gold leaf called size. They wait 12 hours until it becomes tacky. Wet glue would merely absorb the gold, producing a dull finish. Gold leaf crumbles at the slightest touch, so it comes on a paper backing, making it easier to apply. Gold leaf is available in different qualities. The lower the carat level, the more alloys it contains. This is 23 carat leaf, the closest you can get to pure gold. Because it contains no other metals, it won't oxidize, tarnish, or dull, despite acid rain, road salt, or other harsh elements. Using silicone and screws, they mount the lettering onto a painted aluminum frame. Another option would be to mount them on a painted background plaque made of the same foam as the letters. Designs can also be engraved directly into a plaque, then highlighted using either paint or gold leaf. They use vinyl film to mask the parts that won't be decorated. This time, they apply loose gold leaf rather than the kind that comes on a paper backing, because it's easier to brush into small areas. When the gold leafing is done, they carefully remove the film. This factory makes signs in a variety of materials, everything from wood to stainless steel to plexiglass. The choice is determined primarily by whether the sign will hang indoors or out. Besides lettering, signs often incorporate 3D objects made of resin or fiberglass. The factory casts these components in molds, then paints and mounts them. They'll create this sign in various thicknesses of aluminum. The same computer-guided router does the cutting, but now they have to continually douse its blade with coolant to prevent the friction-generated heat from melting the metal. They coat the components with metal primer before applying polyurethane paint. Assembly is simple. They screw aluminum studs to the back of all the pieces, then bolt them onto the background plaque. Thanks to the wonders of computer technology, design possibilities are virtually endless, a true sign of the times. There was a time when exposing your hardwood floors meant you just couldn't afford wall-to-wall carpeting. Not anymore. Hardwood floors are definitely in. And today there are so many wood and stain color choices, hardwood floors can suit any decor. The types of wood commonly used for flooring include red oak, beech, maple, white oak, walnut, birch, and ash. As soon as the wood arrives from the sawmill, workers at the floor factory stack it on racks, then pile the racks floor to ceiling in a dryer that's the size of a large barn. There, large fans circulate hot air around the racks. The wood's moisture content is between 40 and 60%, depending on the season. When that drops to about 7%, the wood is ready to come out. This drying process takes anywhere from 10 days to a month. The length of time varies because some species dry out much slower than others. The wood is in random lengths and widths, so the first step after drying is to cut it to standard sizes. On the way to the ripsaw, the planks pass under an optical device called an optimizer. In mere seconds, it reads the dimensions of each plank and sends that information to a computer. The computer calculates the greatest number of standard-sized pieces that can be cut from the plank, then guides the ripsaw to cut accordingly. This maximizes the yield and limits waste. Flooring is made from medium quality rather than top quality lumber to keep prices competitive. As the pieces exit the saw, workers manually cut out any large knots or other defects, weak points at which a piece could potentially snap and jam up the equipment. The pieces now travel to a machine called the molder. Its revolving steel knives spin at a rate of 6,000 rotations per minute, carving a tongue down one side of each piece and a groove down the other. Workers do frequent spot checks to make sure the tongues and grooves fit together snugly. The next machine carves grooves on what will be the underside of the pieces. This is for air circulation and stability. Then, an embossed wheel imprints the words, "Made in Canada." Using cross-cut saws, workers remove any faults in the wood and divide pieces that have noticeable color variations. This is the first step towards sorting the wood by grade. Now a machine called an end matcher carves a tongue and groove on the two ends. Here's the view from inside the machine. Workers check once again for faults. Then, assessing quality and color, sort each piece by grade. This will be pre-finished flooring, so the pieces now run through a sander to prepare them to receive 8 coats of varnish. For certain finishes, the first coat contains wood stain. All subsequent coats are colorless. Between each application, ultraviolet lamps dry the varnish in just a few seconds. As the flooring exits the last drying oven, it's ready for packaging. Unfinished hardwood flooring has to be sanded, stained, and varnished after it's installed. Pre-finished flooring eliminates that extra work, sparing you the dust, the drying time, and the smell. Drainage pipes are vital to many industries, and they're an important component of municipal infrastructure. Cities use them to prevent streets from flooding in heavy rain. Forestry companies use them as culverts when building logging roads over streams. Pipes are often made of plastic. This corrugated pipe is made from a type of plastic called high-density polyethylene, or HDPE. The pipe factory combines 3 varieties of HDPE pellets: plain ones, recycled ones, and pellets with a colorant that provides UV protection. The proportions vary depending on the pipe's intended use. The mixer transfers the pellets to a machine called the extruder. It first heats them to about 230 degrees Celsius. This melts them into a thick liquid. Then it assembles what's called the corrugator, a mold whose cavity is in the shape of corrugated pipe. The extruder injects the liquefied HDPE into the corrugator, applying vacuum pressure to spread it evenly into all the crevices. A built-in cooling system hardens the plastic just enough to set the shape, enabling them to extract the pipe from the mold. The pipe then passes through a cold water shower, which hardens the plastic completely. The pipe now enters a machine called the perforator, which punches holes around the circumference. These holes, whose size varies by model, serve 2 purposes. First, they make the pipe lighter and therefore easier to transport and install. Second, they enable water to enter the pipe continually at virtually any location, then flow to the end and drain out. It's crucial to prevent soil from clogging these holes, so this next machine wraps the pipe in a filter cloth made of polyester. They don't want this filter cloth to unravel, so the machine heat seals it closed. This corrugated polyethylene pipe is finished and ready to be packaged and shipped. The packaging line is highly automated. Robotic equipment first coils the length of pipe that the customer ordered. Then it cuts the end. The robots tie the coil at several points so that it doesn't unravel. Workers now transfer the coiled pipe to a machine that covers it in plastic stretch wrap. This covering will protect the filter cloth until installation time from the damaging effects of dirt, moisture, and light. This factory also produces what's called double wall pipe, which has a corrugated outside wall and a smooth inside wall. This type of pipe drains more efficiently because water flows faster over a flat surface than over the repeated peaks and valleys of a corrugated one. Making this type of pipe requires 2 extruders, one to form each wall. Samples from every production run go through several quality control tests. This compression strength test ensures the pipe won't buckle under the weight of the earth above it. High-density polyethylene pipe may be lightweight compared to cement pipe, but it's equally resistant to pressure, chemicals, and abrasion. Mattress Anatomy 101. The comfort layer is the quilted fabric top and underlying foam. The support layer is made up of the interior coils and heavy gauge wire along the perimeter. The foundation, or box spring, is a separate bottom unit that acts like a giant shock absorber. For thousands of years, people slept on the floor on pallets, mattresses stuffed with natural materials such as straw, wool, or feathers. During the Middle Ages, family members would set down their pallets around the home's central fireplace. Only royalty and the wealthy had separate sleeping quarters and mattresses that sat off the floor on a wooden frame called a bedstead. Beds didn't become common in middle-class homes until the 1600s. The comfort layer, or quilt, starts with ticking, a cover fabric made of polyester or cotton polyester. Under that are layers of polyester cloth, foam, and fiber. Luxury mattresses contain wool, silk, or cashmere fiber. The assembled layers go into an automated sewing machine. It's computer programmed to stitch one of several quilted designs. A roller compresses the thick pile to enable the 8-centimeter long needles to pierce through all the layers. The 2 polyester sheets inside the quilt are essential. One is directly under the ticking. It acts as a barrier to prevent scratchy fibers from poking through the top of the mattress. The other is at the bottom of the quilt. It holds the stitches in place, preventing the thread from moving around inside and ripping the foam. A cutting wheel now trims the quilt to twin, double, queen, or king size, leaving an extra 5 centimeters all around. This surplus ensures the foam will reach all the way to the edge once the quilt's sewn up. The sewing table is air cushioned, like an air hockey table. This floats the quilt, enabling the seamstress to maneuver it easily. As she stitches the quilt closed, she trims off the excess and sews a polyester band to the underside along the perimeter. Meanwhile, an automated sewing machine produces the mattress sides from the same ticking used for the quilt. It stitches the fabric to a centimeter-thick foam sheet, making a quilted design. Low-end mattresses have unquilted side fabric. Elsewhere in the factory, as we see here in slow motion, automated machines produce the guts of the mattress, the coils. Low-end mattresses contain continuous coils, rows of springs formed out of one long strip of steel wire. Better mattresses contain individual coils, each formed from a separate piece of wire. This machine is producing open coils, a type of individual coil used in mid-quality mattresses. Open coils have an hourglass shape and are made of steel. Luxury mattresses contain pocket coils, individual coils that are barrel-shaped and made of steel, manganese, and carbon, a high-strength combination of metals. The coils are individually wrapped in cloth pockets to prevent them from tangling together. This machine is producing open coils. It first heats the wire with an electric current to make the metal flexible. Once it forms the coil, it curls the two ends of the wire like a pig's tail. This pigtail finishing prevents the sharp ends from poking through the mattress surface. They line up the open coils in rows, then feed them into a machine that connects them by running long strips of pigtailed wire along the tops and bottoms. Using pigtailed wire again, workers attach thick steel edge wire along the top and bottom perimeters, and steel brackets called edge guards at strategic points along the sides. These supports are what keep the mattress firm when you sit on the edge. Pocket coils are glued to each other at the center. This enables them to move independently so that motion on one side of the bed won't affect the other side. A reinforcement netting holds the coils in position. Workers attach the edge wires and edge guards to the outer coils with thick staples. The rest of the assembly process is the same for all types of mattresses. After adding 2 layers of foam, workers attach a quilt to the top and bottom by stapling the polyester band on the quilt's underside to the metal components. The final step is to attach the sides. A special machine called a mattress closer joins them to the quilts with a reinforcement strip made of durable fabric. If you have any comments about the show, or if you'd like to suggest topics for future shows, drop us a line at www.howitismade.net. The How It's Made crew vehicle is courtesy of Subaru Canada.